everyone, and welcome back. I'm David Altfeld with Miller Clapperton, and today we're going to be talking again about multi-face panels. This panel is the same shape as the panels we dealt with in the last video. The difference is that this panel has framing inside. In the last video we discussed how these panels behave when there were gussets inside the panel or chevron clips reinforcing the panel, but no framing to support the panel. I have a deflection gauge set up here, and so we'll be able to measure exactly how much the middle of the panel drops when we load it. Along this back edge, this would simulate a wall, and we have fasteners here at 16 inches on center. We're also going to look at what happens if we don't have those fasteners or if they're further apart. One other important thing to note is that if we look inside the panel, this would normally be a framed wall. This is the back side of the panel here, and this is the wall here. So we have almost a 2-inch gap between the panel and the wall. The only places where the panel touches the framing is at the ends of the panel. Along the length of the panel, there's nothing touching. We're going to be using shims. They're about 7.5 pounds per box to load this panel. Now that we've seen an overview of how this panel is set up, let's talk about how the loads are carried to the framing. If we were to remove these shims, we can see that the panel is very flexible, just like in the last video. But in this video we have framing, so we're going to put a shim here, and if I push down on the top of the panel, the load goes through the extrusion, through the shim, and into our framing. So we've removed the shims and screws at the top and bottom of the panel, and instead we've applied a screw at the front of the panel. But we can see that when we load, it's very stiff. Nothing is moving. The load just goes through the front face of the panel, through this extrusion, and into the framing. I'm going to begin loading the panel. The only screw I have installed is on the front. The top and bottom faces are just floating. So we have a row of boxes along the top edge of the panel. And the panel looks very straight still. It's actually dropped about 1/8 of an inch. So with the second row of boxes, we now have about 1/4 inch of deflection, and I can see it. It's not a lot, but it is noticeable. Okay, let's apply a third row of boxes. So I've loaded this up with all the boxes I have. We've got about 5/8 of total movement over this 12-foot span. It's getting to be definitely noticeable. Now we're going to take these boxes off and see if the panel remains curved. So we've removed all of the boxes, and we do have just a little less than 1/16 of permanent deflection. That's not going to be noticeable on such a long panel. So we've removed all of the screws along the top and bottom edge, and as expected, this has dropped significantly. However, at the front, it really has not dropped much at all, less than 1/8 of an inch. And if we apply a load, we can see the dial gauge moving. At the back, there is some slight movement, but it may not be any more than what's happening at the front. So now we're going to apply one layer of boxes with no attachments on the back of the panel. Unfortunately, my battery died while we were loading the panel without the screws along the back edge. But nothing spectacular happened. The panel behaved very similar to the way it did when it was attached along the back edge. I showed before we did this that the panel had moved down a little, and we can see that the back is very flexible. But the boxes were set to the front, and when we push on the front, the back really doesn't move. Also, with all the boxes on the panel, I was able to stick my hand in from the back and very easily just lift up the panel, even with the boxes on it. So I know the screws on the back were not carrying a lot of load. All of the load from the boxes was coming through this front face and going through this one screw at each end. Ultimately, that's what I wanted to show with this demonstration, is that the fastening at the ends of these panels are the most important fasteners. The ones at the wall are important. Obviously, we don't want this panel drooping down like it is now, but they're not really carrying a lot of load. The screw that's carrying a lot of load is this one, and if we were to apply the screws here, then those would also carry a lot of load. Demonstration was helpful. If you have any questions, please let me know. Thanks for watching.